Welcome to the RTU and Gateway module. In this module, we're going to discuss the RTU, which is an acronym for the Remote Terminal Unit, and its function in the substation. The main function, of course, there is many functions for an RTU. We'll try to cover the main function of the Remote Terminal Unit in a substation. And then we will discuss a little bit about the hardware of a remote terminal unit, redundancy of the remote terminal unit. And the final thing is we're going to discuss about what are the main components that make up the software of a remote terminal unit. We'll close out with discussing the database of a remote terminal unit. Remote terminal unit is a big subject to cover, so this is an overview covering just the main function, the main hardware, and the main software. Hopefully we'll cover more of what the remote terminal unit, specifically the GE remote terminal units, in the future modules. The remote terminal unit, or the gateway, the RTU in a substation, acts as basically the middle box or the middle device that sits between a management system and all the primary equipment and IEDs in the substation. So as can you see in the diagram, we've got all our primary equipment, all the IEDs interfacing to the primary equipment, reporting to a remote terminal unit, through which information flow all the way to the energy management system, and vice versa. You've got controls coming from the energy management system received by the remote terminal units and distributed to the applicable IED or primary equipment. With that, there could be a local master in the substation, in the control room of the substation, which is accessible by dispatched personnel that come to the substation in order to resolve an issue. That local HMI is also accessing the remote terminal unit in a substation. So the main job of a remote terminal unit is get information, monitor. So monitor the information from the primary equipment and control the primary equipment based on requests either from the local HMI or from the remote energy management system or any other management system like a distribution management system. The remote terminal unit consists of a main processor, microprocessor system that has an operating system in it. The operating system is normally a real-time operating system that's constantly running, monitoring all the information in the substation, collecting all of that information and concentrating that information into a local database. It also allows for remote management systems to carry out telemetry or telecontrols remotely to any equipment in the substation. So it will receive that control from the remote management system and then pass it on to the local IED or the local primary equipment. Remote terminal units come in many shapes and forms, and they contain many parts depending on the requirement of the substation or the application. So you might have a small number of data points, maybe like 6 digital inputs, 8 digital outputs at max. Your need is not to have a high-end device that comes with all the bells and whistles. Yet in a different substation, your need is very sensitive. This is a sensitive substation. It requires redundancy. It requires a high-end remote terminal unit that has a built-in HMI and everything in between. So GE over the years have strived to meet the customer requirements and have created many remote terminal units. The remote terminal units range from the mini data concentrator like the iBox to the small point count RTU to the medium to large count RTU and of course the high-end multifunction gateway which supports cybersecurity, supports embedded HMI, that self-served HMI, And everything in between. So hopefully this will give you a feeling and an overview of all the options that are available as part of the GE portfolio, from the iBox to the D25 to the C264, the D20, and the D200, which could accommodate either an ME or an MX, though the formal ME was replaced by an MX board. And of course, the high-end D400, which have its own self-serve HMI and redundant power supply, and it also have its own Ethernet unmanaged Ethernet switch, and it also contains its own KVM that will allow you to access it using a keyboard, video, and mouse. The aim of having a remote terminal unit in a substation is basically to harvest and unlock all of that information and data from the IEDs, and also secure access of users to the utility substation infrastructure. Also have an interface to all the equipment in the substation. The main aim, of course, is to improve the utility operational excellence by allowing remote automation and improving the capabilities of the substation, that these substations not only are no-man substations, so there isn't a person in the substation because the RTU is replacing all the manpower that's required for the substation. At the same time, it is allowing any personnel that is dispatched to the substation to get at information at a very high speed without the need for more software or more hardware requirement. Um, Improving the capability of the substation to have a local HMI that will allow the dispatched person to be empowered to find the fault, locate the fault, and try to resolve the fault in a fast manner. And it does add the ability of a self-healing substation if required. Also, it improves the capability of managing the substation remotely and without any issues with cybersecurity as much as possible, by allowing the interface to firewalls and all of this protection, IT protection, that could be integrated into the remote terminal units. It also allows us to access analytical data, not only operational data, but non-operational data, like we said in other substation automation modules, where we have discussed the difference between operational and non-operational. So all the fault recorders, you have remote access to them, all the metering information, you have access to it. So the management system, the remote management system, now can control more than one substation remotely without dispatching people or having the need to physically be in the substation. In order to manage the layout of the substation with where does the RTU fit in the layers of the substation, depending on who you talk to, the substation, we could divide it into 4 layers, 5 layers, or if we want to have an overall look like what we have here is a simple 3-layer layout where we have put the IEDs and the primary equipment in the same layer. Somebody might argue that this could be 2 layers, that's fine. But if we take it as we have presented here, you could have aggregate fiber optic unit, and then you have the remote terminal unit talking to all of that primary and fiber optic equipment, and all reporting back to the energy management system through a jungle mux or any equipment that's interfacing to the firewall, and from there to the energy management system. So all the masters, the remote masters, will be able to access all of these equipment through the remote terminal unit. Um, and hopefully at this point we have made it clear what is the function of the remote terminal unit in a substation is number one, to collect information um, from all the IEDs and all the main equipment, the primary equipment, back to the energy management system, and then take the controls from the energy management systems and provide it to all the primary equipment and the IEDs in the substation. With the advance of 61850, it can the RTU can also act as a gateway to facilitate the translation of remote um, controls and local information from and to 61850. Um, uh, with this, we're going to move on to the next section where we talk about the two parts of the RTU, which is the hardware and the software. In this section, we're going to discuss the remote terminal unit hardware. Talking about remote terminal units in general, the hardware would consist of a main central processing unit, a microprocessor, of course, in the central processing unit, probably a power supply, and for power supplies we can support either AC or DC power supply. It could be a redundant power supply or a single power supply based on the requirement of your installation or substation layout. Also, you've got serial interface, network interface um, on the remote terminal unit, and you've got the I/O module, or the direct physical connection to digital inputs, digital outputs, analog inputs, analog outputs. This is the main basic components. A remote terminal unit can range from, like we said, from a simple hardware all the way to advanced redundant hardware inside the remote terminal unit. What do we mean by redundant hardware in the remote terminal unit? In this case, let's say that you have two main CPUs, as you can see, two D200 or two D400 sitting in the substation connected to each other. Each one of the remote terminal units have two power supplies. You've got each control or I/O point connected to two I/O modules, and you've got two switches communicating on separate LANs. And some of my modules, I discussed the parallel communication on an Ethernet LAN, which is one of the standards like the PRP standard. And this would allow, if one switch is turned off or is not able to communicate through that one switch path, for the second switch to pick up the communication and still communicate to the D400. Also, the two D400s act as twice the amount of gateway for the master. So if one of the D400 has to be put in maintenance mode for update, or it has to be it has to be taken offline by one of the engineers at the site, the other D400 can pick up and keep that communication going for a sensitive site. And then once the main D400 comes back into communication, we can switch the communication back to the main D400. So redundancy is very critical, extremely insensitive substations where we can't afford to keep the master blind about the information in the substation, about all the events in the substation. And this is where redundancy will serve you best. And you can have redundancy at many levels. Of course, there is a cost to having so much redundancy. So it all depends on the sensitivity of the substation, the requirement of the utility. Next, I would like to show you a breakdown of a hardware of any RTU. In this case, we have picked up the D400 as an example of a hardware overview, so that you have basically a feeling and an understanding for what are the parts of a a remote terminal unit from a hardware perspective.
The Multilink D400 is a secure, hardened, advanced substation gateway that collects metering, status events, and fault report data from serial or LAN-based intelligent substation devices. These devices are connected to the D400 in the substation and collects information from all over the substation concentrated at the D400. The Multilink D400 summarizes the data from the substation devices and makes it available locally or remotely through a standard secure web browser, HTTPS. It supports serial and or LAN connection to SCADA masters TCP IP network. Connections are supported over the built-in Ethernet and the modem interfaces. So the SCADA master, whether it's an EMS, an energy management system, or a DMS, a distribution management system, the D400 can serve all of the data from the substation to these masters that are sitting remotely and concentrate the data, summarize it, provide it to the masters that are sitting remotely, while providing a secure hardened box, 19-inch rack mountable device in the substation. I'm going to explore the D400 hardware with you. So we start with the D400 front of the chassis of the D400 device. The first thing we see is a power supply. Basically, the power supply in the D400 is a redundant power supply, and there's sensors on the back of the D400 where it will allow you to sense when power is lost to the D400 to provide an alarm on D400 power loss. The redundant power supply can be either 100 to 240 volt AC, basically covers the 47 to 63 hertz, or 100 to 300 volt DC and plus or minus 10%. The other choice is 20 to 55 volt DC. And you can have any combinations of these redundant power supplies in the same D400. So that's the D400 power supply connection on the front of the D400 device. The D400 also is equipped with a compact flash, and this is a user compact flash mostly used to collect data from the D400 and to be taken offline for analysis if required. It provides an easy way to access user data on the D400. This compact flash is different from the main compact flash, which is the home of the operating system of the D400. The D400 have also system status LED indicators. The system status LED indicators are used in order to indicate the status of the power, whether the D400 is in ready state, the status of the network connections, and we can have up to 2 network cards in the D400. As such, there is a net1, net2 indicator on the D400 LED system status display. There is also a maintenance connection Ethernet port. There is a USB, 2 USB ports which can be utilized in order to take data from the D400 and for analysis. There is also a front maintenance serial port for serial port access to the user-friendly HMI that will allow you to set up the D400 on a first setting with the D400. So basically we've got the Ethernet, serial, and USB communication connection on the front. The last set of LEDs that are available on the main CPU is the serial port status LED indicators. The D400 can have up to 16 digital, 16 serial communication ports, and the indicator on transmit and receive can show the activity to the user of the D400. All of these parts that I've just discussed, the compact flash, the system status LED indicator, the Ethernet USB, and the serial status indicators, they're all part of the main CPU. The main CPU currently comes in the following five different types. The first one is a 650 megahertz CPU, 512 megabyte RAM with a single Ethernet. The second type would be a 1 gigahertz CPU, 1 gigabyte RAM with a single Ethernet. Or you can get the 1 gigahertz CPU, 1 gigabyte RAM, dual redundant Ethernet. You can also get the 1 gigahertz, 1 gigabyte RAM, single Ethernet, or the 1 gigahertz, 1 gigabyte RAM with a dual redundant Ethernet port. So 16 GB compact flash. Basically, you can either have one Ethernet card connected or two Ethernet card connected. So you can purchase the D400 with the proper main CPU that can support either one or two redundant Ethernet, and the compact flash, the user and the main compact flash can go up to 16 GB in the current setup. Next, I'm going to discuss the reader of the D400. As I mentioned, there is 16 serial ports that can be either RS-232, RS-485, a GFO, which is a glass fiber optic, or a PFO, plastic fiber optic connectors. So as you can see, there is 8 cards in here, with each equipped with 2 serial ports. This is serial port 1, serial port 2, and because 2 by 8 means 16 serial ports. The next card is the IRIC-B input to the D400. So the IRIC-B input slot to the D400 is how we collect the time from the substation so that the events in the D400 are logged with the proper time if they're logged locally. And the D400 has the capability of distributing the IRIC-B through the IRIC-B distribution slot. So the IRIC-B distribution slot we can add a card that we can take the IRIC-B input and also give it as an output for the rest of the devices to sync off the IRIC-B time. Also, we explained that the D400 can accommodate up to 2 Ethernet switches. The types of the Ethernet switches, currently we support 3 types of Ethernet switches. You've got the Ethernet 4-port 10100 megabyte switch. We also support the Ethernet fiber optic hot standby 2-port 10100 base SX, and we support the D400 100 base FX hot standby Ethernet switch. The D400 also have the capability of supporting a KVM slot. KVM stands for keyboard, video, and mouse. D400 is just like your any PC, standalone PC. So we can connect a keyboard, a mouse, and a video screen, which will allow us to access the D400 without the need of an external PC. I think that's a great enhancement of the D400 concentrator. As explained earlier, the D400 supports redundant power. The power can be external, provided to the D400, either 100 to 240 volt AC or 100 to 300 volt DC. We also provide the option for 20 to 55 volt DC. This is the top connections. The bottom connections basically provide a sensor for loss of power. So in case the D400 loses power, we can provide an output that would highlight that the D400 have lost the main power connection.
Now that we understand the hardware, the last piece, that section that we're going to discuss is the software of a remote terminal unit. The hardware of a remote terminal unit will assist the software part in getting all the interfaces to the serial communication and the power to the CPU. The software in its place will function in order to keep the communication between the management system and the IEDs going back and forth. So it normally consists of an operating system. That operating system could be either an embedded or a real-time operating system, and there is advantages and disadvantages to whether to use an operating system that's real-time operating system or an embedded. There's other modules where I discuss the differences between these two operating systems. And the operating system will basically have different applications on it. There isn't a consensus on what to name these applications. Just take it for the sake of this argument that we're going to have a data collection application and a data processing application and a logic or a translation application. If we would like to take a look at the software design of a remote terminal unit, what you will find is that the heart of the software is always the operating system. Operating system could be a whole bunch of applications that is basically handling the main hardware interfaces, like interface to the serial port, interface to the main processor, interface to the memory, and it does that in the most efficient way possible. On top of the operating system layer, there will come a data processing application or a server application. That application will basically communicate to the management system. And from the other end, opposite end of a server or a data processing application is a data collection application or a master application, depending on the architecture of the remote terminal unit, or sometimes it's referred to as a client application. So the opposite of a server application is a client application. The client application or the data collection application will basically communicate to primary equipment or IEDs in the substation, like you've seen in the previous slides. When communicating to all of these IEDs and primary equipment, what the RTU is doing, it's harvesting real points and real data and basically archiving it in a database. Like I'm showing you in the diagram, this could what's referred to as the point database or real point database, whatever you want to name it. The points that or the values that is in the database could be categorized into 6 pieces: digital inputs, digital outputs, analog inputs, analog outputs, and counters. Now, new categories are showing up like complex objects, which would combine some of these parts. Like one complex object could be a couple of digital inputs, a couple of digital outputs. If these points are not coming from the field, they're not real points, right? They could be, there could be application that act inside the remote terminal unit architecture that would either create a new points out of the real points, which we like to refer to as calculated points. And these points are also stored again back into the database. And these points could be either real points, or those calculated points would be reported back to the energy management system through the data processing application or the server applications. In the previous slide, I covered the real and soft points very quickly, and I would like to just put a little bit of emphasis, because in my classes it has been always a point of confusion for the students as to what's the difference between a real point and a calculated point. A real point, again, is a point that comes directly from the field. It has a raw value on it. It does not, we don't alter that value. We just take the value directly from the sensor as we read it from the sensor, and we store it directly into the database as is. The soft point, sometimes referred to as a pseudo point or a logical point, is a calculated point. This calculated point could be either a calculation from a direct point, like let's say you have two digital inputs and you're ORing those two digital inputs into this soft digital input. The value of the OR does not exist in my substation. It is a point, it's an alarm that we create directly into the database. So that's not a point that is coming from the substation or any of the primary or any of the IEDs, but instead it's calculated inside the remote terminal unit, soft point that's created inside the terminal remote unit. Another calculated point could be a point about the status of the remote terminal unit. Let's say the remote terminal unit has a low power alarm or has shifted from the AC to the DC power source, or the power was lost on the main power supply and we shifted to the redundant power supply, or communication was lost to one of the IEDs. All of these points that are talking about the status of the remote terminal unit or the status of communication between the remote terminal unit and the field are considered to be also pseudo points or soft points that are basically stored in the database of the remote terminal unit. So I hope with this explanation that there is a clear distinction and you are clear about what's the difference between a soft point or a pseudo point and a real point or a hard point that's coming from the field.